So for this video segment, what I'd like to talk about, it's a specific type of covalent bond. And there's two types of covalent bonds, actually. The first one is polar covalent, but a couple things to remember. The electrons are shared, and generally two or more nonmetals make covalent bonds. And so now what we want to take a look at is the sharing. As those electrons are getting shared, the sharing is not always equal. Sometimes one atom is called, I'll call it an electron hog. And so if we go back, if we take a look at something, where's my water? So if I look at water, down here, looks like kind of the Mickey Mouse silhouette there. Those electrons, remember, are spinning. So they're being shared. So they're spinning around the oxygen. They're spinning around the hydrogens. But what happens is oxygen, in this case, is an electron hog. And so those electrons are spinning more around the oxygen. And so I'm just drawing more circles showing that the oxygen is an electron hog. And every once in a while, the hydrogens say, well, remember, I'm supposed to get those electrons. And so oxygen will share a little bit. Oops, but then they keep going right around the oxygen. And so when we look at this, the sharing isn't equal. And since those electrons are spending more time around the oxygen, electrons are negative, so the oxygen carries a slight negative charge, and the hydrogen side carries a slight positive charge. Well, scientists call these poles. Just like the North Pole, South Pole, they call them poles. And so when we're looking at polar molecules, we've got polar covalent bonds. Due to unequal sharing, the atom has a slight charge. And again, in water, oxygen is slightly negative, hydrogens are slightly positive. One side is slightly positive, so it's got a positive side. One side is slightly negative, so it's got a negative side. And that's just where that term pole, scientists generally don't use the word sides, I guess. They like to use that word pole. And so we call these polar molecules. And so water is polar. Again, oxygen's the electron hog. Those electrons are spinning around oxygen. We see right here, it's negative. And then eventually they do have to sometimes go around those hydrogens, but then it spins around the oxygen. Hydrogens are slightly positive because oxygen's hogging it. So technically speaking, yes, that oxygen is sharing the electrons, but it's just not sharing very equally. Somewhere where these come into play, here again we get hydrogen bonds because this side is slightly positive, this one's slightly negative, so there's a slight attraction there shown by the dotted line. And so water is filled with all sorts of slightly positive sides, slightly negative sides. So water molecules, believe it or not, are attracted to each other. And that creates something called surface tension. And so if you look at this water strider, you can see its legs. It's not actually in the water. You can see where its legs are actually just kind of sitting on top of the water. You can see it's actually just pushing down on the water just slightly. It hasn't broken that surface tension. That these dotted lines, that water strider is sitting on top, and I can't draw bugs very well. There's my little bug, but it's sitting on top of those hydrogen bonds, and it's so light it doesn't break those bonds, and it just rests on top of the water. You and I, we can't do that. We're just too heavy. Those hydrogen bonds can't support us. And so we've got polar covalent bonds in water have that slight bit of attraction to each other, and something like a little water strider can take advantage of that and just skitter across the top of the water, not actually ever being in the water. Now, there's fish underneath the water, of course, that get kind of hungry, and sometimes they'll swim up and eat the water striders if they're not careful. But that's a whole nother story for biology. And then we have non-polar covalent, non meaning no poles on this one. So the sharing is equal on this one. And so since there's equal, there are no poles with this type of bonding. And so with a nonpolar covalent molecule, I'm going to go way back here a little ways. And so what happens is, I'm going to try to erase again. And you see I'm not sure why my eraser isn't working the best. Oops. I don't know why. Well, I'm just going to go drop back to drawing then. So in terms of polar covalent, oxygen shares equally with oxygen. And so those electrons spin equally. They're spending the same amount of time on both sides. And since those electrons are spending an equal amount of time, we call that a nonpolar molecule. There are no poles. And so here, oil is nonpolar. Again, the idea, it spins around the carbon, hydrogen, and it's doing this equally. And since those electrons are being shared equally, there are no poles. So water is slightly attracted to each other. Something like oil is nonpolar. Those atoms are, or those molecules are not attracted to each other, because all the way through this molecule, those electrons are being shared equally, and we don't have any positive or negative sides. And so we call those nonpolar.